Hello, everyone. All right. So today we're going to be doing some quick design work inside of Unity here. I'm going to be pretty much going over some of the first steps I take when going into a project, as well as hopefully setting up some basic scriptable objects. My whole idea here is to actually create a sort of Katamari-esque game. Call it a clone, if you will, where you're going to be a little mouse on top of a wheel of cheese, and you're going to be running around levels and uh, collecting some actual like little pellets of cheese to build up your cheese wheel. The bigger the cheese wheel, the more cheese you can collect, and so on and so forth. All right, let's go ahead and just get started here. So creating a Unity file here. Let's go ahead and just start creating some folders here because I know for sure I'm going to need a scenes folder. I'm going to, looks like we already got a scenes folder. I haven't actually created one of these projects in so long. All right, delete these example projects, assets, what's under presets? I can get rid of those. Get rid of the scene. This scene as well. Yep, nope, getting rid of that as well. We can keep the renders and tutorial Gonzo. All right. Let's go ahead and create our scene here. Doop. Destiny, let's go. All right, so test scene here. We're going to go ahead and start out with some basic stuff here. So let's go ahead and just create a terrain plane that we can go ahead and play around on. Gives us a nice checkerboard pattern here. And first off, let's go ahead and just create our little character here. I like to call him Igor. He's going to be a little capsule guy. Let's give him a little sphere. And face him forward. Now he's got that nice little hunchback. Wonderful little Igor guy. Create an empty. Call it Igor. Yep. Alright. Igor is going to be on top of a cheese wheel, so let's just go ahead and create that cylinder here. Let's go ahead and just do 2 by 2 by 0.5. That seems about right. Rotate that 90 degrees, and let's give our little Igor here nice little step up. Oh, I also forgot to center everything, so let me go ahead and do that really quick. Easy way of doing that would just be to go through here, train empty under capsule, drop that down. There we go. Alright, we got our little cheese wheel guy here. I need to make another child. Second empty here. Alright. Drag this down over to here. And we got the bottom of our character. So let's go ahead and call this player. Call this Igor. And we'll just drop it underneath of player. And we'll drop the cylinder under player and call the cylinder cheese wheel. Sweet. So now we got a couple of spots here. We got the art assets under Igor. We got the cheese wheel. I am tempted to make another one under cheese wheel, but we should be. Let's go ahead and do it. Cheese wheel, parent U. camera player, and we'll call you cheese wheel cheese art. There we go. All right, beautiful. Let's go ahead and grab ourselves a. Actually, let's go ahead and import some Cinemachine cameras in here because that will definitely be nice. Get us that nice look that we're going for. Also, let's go ahead and shrink Igor down. I think that would be pretty good here. Let's create another child and just shrink him on down. Beautiful. All right, so let's go ahead and import some Cinemachine cameras. Cinemachine. Let's go install. So my whole thought is, we could probably get away with doing some scriptable objects for the items today, and hopefully get the camera system tied to the character position to where we would want it to be, and hopefully get some form of nice-ish camera down for this one. We'll probably work on the mobility coming around next time, since that'll take a little bit more time than what I would like to give it today. But yeah, let's jump into it. So for Cinemachine, we're just going to go over here and start grabbing the presets. So let's go ahead and create a virtual camera here. That virtual camera is going to set us up over here. I'm pretty sure what I want to do is grab a, not a free look. Virtual camera should definitely do it for us. Pull this guy out over here a little bit, solo it, so we can actually see it down here, and that is what we're seeing in the viewscape right now. We want to go ahead and drag it over to Igor, so we want to focus it on Igor. You know what? Actually, we could probably do some really fun stuff with having it look at the wheel. So let's go ahead and try that out. Grab the wheel. Priority 10 is super fine. Go ahead and zoom it on in a little bit. Raise it on up. And let's change the aim. So let's have it aim a little bit further up here. Let's have it up a little bit more so we're getting a nice down angle. Let me just grab my reference here really quick. Yep, that looks about right. We're gonna open up the box a little bit so that we can have just a little bit of dead zone here. Essentially, all this is going to do is let our player actually move a little bit before the camera starts to shift. That's going to give us a really nice feel. Really, really nice. All right, we're gonna also shape down the dead zones a bit because I don't want this guy going off screen. I want the camera to be able to keep up with him for the most part. All right. As far as lens goes, that should be pretty good. And as far as transitions go, we don't really have to worry about that too much. If I go ahead and play blast this really quick. What is my camera? How are you updating? All right, let's see. So we don't want that. Timescale should be on. You know, I don't think we actually made an actual rotatable camera. I think we just did a basic virtual camera. All right. Is it a free look camera? Yeah, it's a free look camera. All right. Let's just copy this component, paste it on in here. Actually, no, we can't quite do that, can we? We gotta, can I copy component values? Nope. Nope, I cannot. All right, let's repeat that then. We want a free look camera. Be looking at player. Doop, doop. We want the aim offset to be up a bit. This is exactly what I was looking for. All right. You want the look ahead time to be just a little bit. Look ahead smoothing to be up a little bit. Dead zones to be just about there for all of the rigs. Yep, perfect. All right. You want the, at least the middle zone to be a little bit more up. And want the general aim distance to be quite a ways away. Where is that at? It's been a while since I used these guys. All right. Aiming. Let's go. Oh, I also forgot. Let's get some music on. That will help tremendously, won't it? Just a bit. Huh, I am seriously not seeing the aim function. As well as the dampening. Radius. That's right, because this doesn't actually have a zoom, it has a radius. Alright, overall, let's go ahead and save during gameplay and actually playtest this, and then we can tweak the values as needed. Alright. So we can tell there, the bottom one is definitely going to need to be raised up quite a bit. Oh, that is the top one actually. Top one needs to be raised up a bit. Then the radius can be shrunk in a little bit. So we can get a nice top view of the mouse. Might want to up the height just a bit. There we go. Bring it way down. Let's go ahead and change this height just a bit. I'll make the radius out a bit. And smooth that radius in just a bit. Alright, so right about middle there. We want to raise this down. And we want to raise this up quite a bit. That should be about normal. can raise this up just a bit as well, so it's not so far down. There we go. Beautiful. All right, so that takes care of the camera for the most part. We can always tweak it a little bit later. So the main thing with Katamari is that you're always rolling up stuff. It could be small items, it could be big items. There's 3 defining factors per item, though, I've noticed. One is the mesh. One is the actual weight or size of the item, essentially the dimensions of it. And that is about it. Other than it can potentially have animations, be running around, it could be stationary, etc. So my thought is we probably hook this up to a scriptable object for the most part. Have the scriptable object contain a mesh, a pretty much all the information that it needs for it, which is the mesh, the actual size of the object, as well as that prefab. So instead of doing a mesh, we could always have it be hooked up to a prefab, which would be even better. And then that prefab would just have essentially the mesh data, the animation data, anything else it needs, and it can easily track. So let's go ahead and start that off here. And let's create ourselves a new folder. All the scripts. Nope, we actually already got scripts. All right. Let's create a folder inside a folder. Scriptable object. And let's get to it. So, all right, we're gonna need a scriptable object. And let's call this cheese. That's probably the best way to put it, is just cheese. All right. So, good old writer here. Let me reshape some stuff over here. All right. Oh. All right. So now with this going on over here, what we can do is start on it. So we're gonna want a scriptable object. We'll want an ability to call this object. Let me just grab a quick temp so I don't mess this up. Create assets menu. Let's do this Chedamari object slash cheese data. Let's order this to 1. Alright, and that should show up in our list up here when it compiles down there. What have we got? We got no errors, so that is a-okay. Yep, right here. So Chedamari objects cheese data create. Beautiful. Alright. So, we got our cheese now. Let's go ahead and start giving this guy some data. Alright, so the first thing that we're going to want to do is define a couple of things. So we want a name for this cheese. So let's go ahead and do string name. Oh, let's make this public, please. Public string name. Let's go ahead and do another public string. Oh, we want a float. Let's call this size. Yeah, let's go ahead and just do that, and then we can actually cut it down based on meter to centimeter, and just do a quick float / round on top of that for whenever we actually pick it up, so we can actually give the user if it's in centimeters or meters or how big it is, roughly, and give it a nice point. So we'll stick to size. We'll give ourselves a quick note here. Centimeters. Actually, we can do this as a tooltip. One of my faves. Alright, so tooltip sizes in centimeters. What else do we need? We need a prefab, so public name object. I has a bad feeling that it's not lighting up. We should be able to call game objects. I'm pretty sure. Does this break? Breaks, I'm gonna be sad. Oh, tooltip attribute. Alright, let's just get rid of this and make that a comment. And we can worry about making it pretty a little bit later. Now it doesn't spark. Yeah? Alright. Let's go ahead and just create a basic cheese. Let's go ahead and create a new folder. Call this data. Let's make another one. Call it cheese. Let's create our cheese data. Yep, sweet. Alright, there. It's all good. Alright. I was freaking out there for a second. I'll call this cheese data. Ooh, you know what? We could probably do that. Nah, I'll save that for later. Let's call this cheddar cheese, cheddar data. Cheddar. Oh, it's cheddar cheese. Size, let's give it 10. So it's 10 centimeters big. And prefab, let's go ahead and wait on that. So we have the name, the size, the prefab. Is there anything else that we possibly need in this guy? Don't believe so. I think we should be pretty good. Alright, so that's good on that. Let's go ahead and create another scriptable object here. Call this level data. And all levels essentially follow the same sort of premise. Essentially, you have a timer, and then you also have a size requirement. And then after that, you always have like some special things. In our case, we're gonna want to carry over most of that. So let's go ahead and open up a new file here. Call this level data. Let's make this another scriptable object. Throughout here, we're going to have, you know what? Actually, let's do this. Let's have a string. Call this. Give it a name. So we can name our levels, which will be fun. And then we can also pull from this when we're also showing the level data. So we can always show it like, hey, this level is 15 minutes long. You gotta get this size requirement. We can always give high scores as well, which is pretty awesome. Although high scores probably wouldn't want to do it in a scriptable object. But all right. So we got a name here. Let's go ahead and give a size float. Size needed. Let's also give this a public float time limit. How do we want to break the time? I guess essentially we're never gonna have any level deal with seconds. So let's go ahead and make this time will be in minutes. So let's go ahead and make it minutes. And that should be good to go as well. Let's also make a list, though. We could actually make it a class. That would even be better. So let's go ahead and do that. We're gonna want to make this level achievements. All right. Let's drop this under scripts, under miss file. It's data types. Shoot. All right, and then under level achievements, we're gonna want to make this its own class. And essentially, the fancy thing here, we're gonna want to make this system serializable so we can actually see it. And the big thing here is that we want to essentially make ourselves a data class so that we don't continuously have to call out the same data types every single time. So we're gonna have specific requirements. Let's give it. Usually in Katamari they would give you a star because you're making planets. In this one, let's. I think we can think of something even cooler, but let's go ahead and just do a 5-star rating system. So let's do float. Public float. Star 1. Well, we don't. I don't necessarily need a star 1 because star 1 would just be completing the level. Actually, you know what? Let's do it. Star 1. Achievement. Public float. Star 2. Achievements. Float. Star 3. Although star 3 is probably, if we call it that, star 3 would just be completing the level. So we can just keep it this way to make it easier. Alright. Then what's even cooler is that we can actually make a script to run through our entire level, grab the percentages that we want to run this off of, and then kind of just custom implant that into our data code. That would be just spectacular, honestly. All right, so we got our achievements. Let's go ahead and do a public game object. Can we have references in scriptable objects? I don't think we can. We cannot. We can do though is have a set that hooks up to our actual like database for the save system, and then have it reference a bunch of booleans. So let's go ahead and do that. So bool special objects collected, so we can actually do some like costumes or something like that, or hats. Hats would be really cute on mice, I think. You do a Santa hat. Let's do it. So we got stars, we got special objects collected. Anything else do we want? No, I don't think so. I think that's about it. Music. Chill. 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 Thank you. Okay. We have been chilled. Alright. So, with that in mind... What's going on here? Oh, yeah. We'll capitalize this. That should be good, right? Rename to name. Yeah, it doesn't necessarily make sense with what I'm doing. What else you got here? Add a new keyword. Yeah, let's do that. We'll do this as a new name. We also gotta do that down here as well too. To cheese. All right. So, with that said, we got. All right. I think that should be good. Yeah. We got stars, we got objects collected. That's probably going to definitely be moving. So we can't necessarily implant that. Under level data, we can now reference this class here. Achievements. All right. And now under data, we can now create another folder, call this level. And we can create, I lied because we got to call, create asset menu for it. Call this level data. Level. All right. And we got it, which is all good. Call this test level data. Call this test level. Size need, let's do 100. Time limit, let's do, let's just give us 10 minutes. That works. Under achievements, let's do, what, 20, 40, 100, 50, 25, 125, 150. Beautiful. Alright, let's go ahead and make our little cheese guy. And under our cheese guy, we're going to want to make another script. Call this environment. Oh. I want to make a C#. Call this collectible. Collectible item. All right, let's go ahead and get a little bit fancy here. So I want this to reference a mono behavior, and I want to pretty much fill this out with a bunch of basic class types. The point of this is so that we can actually have different types of collectible things. While the main objective is to collect cheese, I think it might be fun to maybe bump in like maybe a bomb or something like that you could collect and it negatively impacts you. So this way here you have to be a little bit careful of what you're collecting and what you're doing. So let's go ahead and just start making up a base class. So let's go ahead and do... We're definitely for sure going to need... Grab references. We don't need to make that public. Let's make that private. And we're always going to attach this to a... Actually, we don't... So if we grabbed a ton of scriptable objects... Actually, no. We can grab the scriptable object and place it on there, can't we? Public scriptable object. Call this data. We call it data. Beautiful. That means under cheese we no longer need the prefab because it's if we were to spawn anything, we would need that prefab, wouldn't we? Yeah, we would. Kind of useless though for the most part, but all right. Create a... Let's do another cylinder. I like cylinders, although they're expensive as heck. Let's do it. Let's create just a basic material here. Paint it yellow. All this cheese. Cheese material. Oh, we'll place it on here. Alright. So we know for sure this guy will always have these components on him. They will always have some form of collectible item, which will then always have some form of data. Awesome. So with that, we can always do different things. Like, for example, every time that you collect it, it needs to do essentially two things. It needs to add something to your total pool of items, and then it also needs to showcase itself to the UI. Currently, right now, we don't have anything with UI to work with, so let's just go ahead and sudo up that section really quick. So we need two public methods. Public, internal, let's just do internal. That sounds, yeah, internal I believe is the one I'm looking for. Let's do an internal collided. Let's do collision occurred. So under collision occurred, we want to do two things usually. It's going to be an internal update UI, and then another internal update size. We're gonna want to grab. We can. Well, there's two ways we can do this. We can either make the player static, or we can grab the player upon every collision. I'm thinking let's make him static because that sounds to be more reasonable. Checking collisions like that is probably not great. Not very fun. Although we do have to do some of that, just make sure that nothing's being hit. But we can force that through layers, which is nice. So let's go ahead and go through here and let's do managers. Well, let's do game manager. Hey, that works. Create a folder. Call this managers. Jag the game manager in there. Under the game manager, we're always going to want to have a static, public static game objects player instance. And we're always going to have a static game manager, and I'll call this instance. I actually don't need a public static for that. We can just call this player. And underneath of here, we're just going to do a quick public awake method, and then instance equals this. So this way here, we always make sure we grab that instance. And then under chess collectible item, we're just going to have your update size. Oh, we need voids in here. We're not really returning anything. Beautiful voids. And we also need to capitalize this for appropriateness. Shoot. All right, beautiful. So under update size, we're going to grab the player. So let's go ahead and do game manager dot player dot instance dot player. We're gonna want to do another script, and let's call this player manager. Since we're only really gonna have one instance of a player. All right, so under player manager, let's go ahead and do float protected float size. Cheese size. Let's do a couple of open ones. So we'll do public. Oh. Let me turn off use Steam. Good old steamers. Ah, shoot. Steam. Exit. No more. Alright. There we go. Nobody's gonna see that. Alright. So, we got the cheese size. Let's do a few things. So we want to make sure that we're pretty much calling this method anytime that we want to update the cheese. So we're just gonna do public cheese size. That works. That works very good actually. So let's actually not do that. Let's do public void set cheese size. Thank you. Pass in here a float. Size difference. Amount. And then let's do cheese size plus equals amount. And then we can run through different animation types. So actually, we could do something really fun and just have it shoot out different types of cheese depending on the negative amount. So we could always do it that way. That might be really fun, actually. More visually appealing too. Alright, so cheese amount. Alright, so let's go ahead and do cheese size. Let's run through the... Nah, not player manager. We want collectible item for sure. So updating the size. Updating the size needs to also apply this object to the cheese wheel and position. So we just want to parent this now to the cheese wheel essentially, and turn off, or we should be able to just turn it off. If we have to, we can always delete the good old colliders. Also, hello person, how's it going? How's it rolling? Alright, so we're going to grab the player instance, and then we're also going to set... Actually, we should be not calling the player instance, we should actually be grabbing the player script. So, player manager, wait please, thank you very much. We're also going to need to make this an instance. Alright. So the instance here, equal this, thank you very much. So clickable item here can now reference this guy. Actually, do we even need the game manager now? Oh, no we don't. Player manager.instance. And we're also going to want to set cheese size to data dot... What's wrong with data? Cheese size. Size, what is wrong with you? We got name. We don't got anything of the data, do we? That's because we're not referencing the cheese. Alright, reference cheese. Beautiful. Alright. So now we got the data.size. Let's go ahead and continue onward. So we need to parent this guy here. So we're going to do transform.parent to player manager. Under player manager, let's go ahead and make a cheese wheel. We'll do a transform. So under the cheese wheel here, we can parent it. And that should get us an easy cheese to attach to this wheel. I need to do a set parent. Set parent? Alright, there we go. Alright, so let's go ahead and start hooking some stuff up here. So we got player here. We of course want to set up the player manager. We're gonna want to put the cheese wheel in there for the transform. Alright, so that should be good. Let's make another one. Let's call this game manager. Place at the top of our list here. Attach game manager to it. Under cheese wheel, or cheese, we should probably start hooking that up as well with collectible item. No need, it just carried over, which is nice. So we got update size, update UI. We're gonna need a mesh renderer. Are we gonna be referencing the mesh renderer though? Yeah, probably better to have it. Mesh renderer. Alright, beautiful. On internal, let's do start. The main reason for making all this internal is definitely so that we can later on, since we're making this kind of like a parent class, We can make subclasses of this and then start to tweak some things if need be. So on the start of, let's say, like a bomb or something like that, we can always easily go ahead and change how that essentially comes into the scene. And we can also force updates. So for example, like a bomb, you wouldn't necessarily want to update the size by setting it to the wheel. You just want it to disappear, so we can always override that, which is nice. All right, so under start, we want to get mesh renderer equals game objects dot. Oh nope. Component. All right, so with that said, let's go ahead and start with the collision. So we're always going to have void collision enter collider other. All right, so do we need to test if it's the player? That's the question. In terms of layers, we can actually set that up now, which is pretty nice. So let's go ahead and grab, is it edit? Just grab add layer. Nope, that's not really going to help us out. Yeah, it's under project settings. Project settings, physics. There we go. All right, so we're going to want cheese. We're going to want layer. Easiest way just to make these collisions only happen on one another. Ooh, I lied. Actually, no, we do need to test if it's the player because we want the cheese to actually interact with the environment. We cannot turn it off. All right. All right. So under other tag equals player. Begs the even better question. So if we're gonna have a lot of cheese in this, let's actually do it under the player. So this way here we're saving resources because good golly, having 500 checks if the cheese hit the geometry is just gonna be insane. All right, so void. We don't want to make this public. Collision enter game object other. If transformed tag is equals cheese. Let's just do collectible. And if other dot transform dot physics. And I'll worry about that later. So if it equals collectible, we're just going to want to run through its components. So we're gonna grab the component other dot get component. Gonna run through this through collectible item, and then run through collision occurred. Perfect. So this way here, we can also have other things potentially have collision occurred. They need to tag collectible though. We can always change that later if need be. Let's see, what are you wanting to do? Convert to a compare tag. Yeah, we're fine with that. All right, so collision occurred, let's just call update size and update UI. Perfect. And I think that solves most of that actually for our collectibles, except for update UI. Let's also get components, so that this way here we're also not running into it. We're gonna want to grab the collider. So collider dot enabled equals false. Then this way here, if we need to, we can always call a new thing. So internal void dropped. Then we could just turn on the collider again. Rigid body, we're also going to play with that as well here. So let's go ahead and grab the cheese. Rigid body. Actually, we could just set this as kinematic, honestly. Rigid body. Rigid body. You. Alright, so my whole thought is, if we're gonna have 500 cheeses, it's probably a bad idea to do a start method on them. A lot of the stuff we can always grab beforehand, but for testing purposes at least, until we actually start to make the objects, I would just do get components. Faster testing, easier to do. Travels between scenes, which is nice. Alright, so let's go ahead and grab that rich body. I just realized we could actually grab a collider as well too, huh? Private collider. Let me just replace these with coal. Yep. Alright. Turn this to true. And false. Oh. Yes. Actually, you know what? Easier way of doing this. Let's just do another method, huh? Internal void. Set rigid body. I'll call this bool on. Alright, so if rigid body is going to be on, it needs to have is kinematic set to true or set to on, and it's also going to need the gravity, so we can at least have the cheese bounce around. Plus this way here, anything else that we need, we can easily start to set that as well. And over here, technically collider is part of that, huh? So let's just do collider on as well. Equals on. Set rigid body. Turn this to true. Or actually, we want this to be false because we're turning everything off, so it could be part of the cheese wheel. And then dropped, it needs to be set to true. And while it might seem very bad to do this all in like one script, like come on, dropped is just one line. It's great to have everything self-contained, so this way here you're not traveling between like 50 scripts wondering where in the heck is dropped at? Why is it calling this weird set rigid body? I have no idea. Well, now we know it's because it's being dropped. Plus this way here, we can also apply different changes like update UI. Actually, we should do that. Updating that UI. Alright. Got a little bit of extra time left. Let's go ahead and create another manager here and start up on the UI. So Katamari usually has UI in the top left, or bottom left, and the right, I believe. Let me grab a quick screenshot. Yeah, so you have your little guy in the bottom right, and you got the top left, and you also got the timer in the top right. So let's go ahead and do a timer GUI. How do we want to do this though? Good question. Let's go ahead and start making a canvas. So we got the UI. Let's drag out the console window for just a quick second. We'll call this level GUI. Under level GUI, we got 3 main sections. So let's just go ahead and screen space. Let's do camera, scale with screen size. Thank you very much. So it can actually scale with the screen. Woo! All right, I always forget if it's raw image or if it's with image. I'm pretty sure it's with image. But what's pretty cool is that we can, let's say, select a sprite, knob in this case. We can change the image type to being filled, and we can essentially cheat here. So for the timer, you essentially have 2 major points for it. You have the little hand, you got the circle, and you got another circle on there. That's spinning with the hand, I believe. Actually, no, I lied. The second part of the circle is just when the timer is 1 minute. All right. So that could actually be with the art, which is nice. But for the most part, oh no, wait, I lied again. The highlight surface is actually time left. All right, we're gonna go from top. Is there a way to go from the right, counterclockwise? Perfect. Okay, so now that we have the fill amount, we can essentially do this pretty easily, which is awesome. We got our start position as well for the UI. So let's just go ahead and create another image here. And let's create a null for my sanity. Sanity time. All right, we're gonna do this clock. We got the hand. And we got time left. And we got hold time. Let's go ahead and take off filled back to simple. Dim this down just a bit. And we can turn off the hand for now. Actually, we can keep the hand, shrink it down. Perfect. All right. So we got time left. That needs to be above. Total time needs to be below. Awesome. So under level UI, we got 3 main components to the clock hand. Let's actually go ahead and do a quick capsule for this. We need a capsule. No, not really. Flip it. Let's actually start using uni.engine. UI, thank you very much. Public sprite. Time left. Public sprite. Clock hand. You know, now that I think about it, it might actually be really fun to use some animations. Actually, that would be... You know what? Let's do that, actually. Let's do it. Animations. That would be really fun. Alright, music. Password. Thank you! Animation. We need an animator because this will only work with that, I believe. We need an animator. So let's go ahead and folder animators. UI. Let's do animator controller clock. And this way here we can also do some fun stuff with it. Need to create an animation. Man, this music is not grooving with me, huh? Alright, I'll fix that next stream for sure. I do apologize. Alright. New animation, let's call this timer. Drag that over. Since clock now has that, let's drag over our clock. And then we can essentially pop open this animation here. We want to add properties to time left. We want to grab the image. We want to grab the fill amount. And we also want to grab the hand and its rect transform. Mostly it's rotation. Yeah, rotation. All right, so under fill amount, we want to place this at 1. And we want to place this at 0. If I can move my mouse all the way over to the right. There we go. So now we got a nice timeline of 0 to 1. We pretty much do the same with this. So if we record this position here, we essentially just want to record 1 full rotation. Negative 360. Beautiful. Pivot is out of place. We could actually do a parent for that to fix the game object value. Great. Thank you. Grab this down to there. Grab this, place that there. Beautiful. Alright. So let's go ahead and fix this up. We want to fix the rotation. Oh gosh. Alright. Grab that rotation. I lied. I'm gonna grab this game object rotation, rotate it. Negative 360. Make it beautiful. Zero. Negative 360. Come on. Beautiful. Alright, so hand pivot. Thank you. Alright. And it's missing. So I renamed it. One more time. Oh. Oh. Well, that's weird. Okay. 0. 360. Alright. The whole point of this is so essentially now that we have this set up in our animator, animation scale is on a 0 to 1 basis. So if we know that it's on a 0 to 1 basis, we can easily start to dictate what's going to happen, especially if this animation is a full 1 second. And that's where the fun comes in. So if we want to play this in 60 minutes, all we have to do is just change the speed. And then it's beautiful. It's golden. Which is frankly amazing. And what we can also do is change the motion time. So what we can do is just add in a float, call this time, and then change the motion time to time. And that gives us an easier window of actually manipulating this piece of GUI to replicate a full level length and never actually have it count down time. What's even better is now with animations and stuff like that, once it hits 0, we could actually call an event, and that event can then end the level for us. So we don't even actually have to keep time at all. We just have to figure out the amount of time that goes into this animation. I love animators. They are the best. All right. So with that said, let me just double check to make sure I'm not running late. All right, looks like I still got a few more minutes left. For the UI here, I'm gonna want to grab the animator. Animator clock animation. All right, so we can get rid of those two things. We don't need them anymore. The clock is now being controlled all through animation, which is very, very nice. Let's do a... do public. So this way here we can actually change the time, and we can maybe add like clocks or something like that to make the level last a little bit longer. All these game design techniques. Woo! Alright, so we're gonna want public. We're gonna want to return a value. Calculate animation time. And we're gonna return a float. Alright, so with that said, we're gonna want to create another float. So float time needed is equal to, and let's just crank out our calculator really quick. So let's say we have a 6-minute level. That's 60 times 6, 360 in total. Wow, I lied. We're all dealing with the second. So we just need to, well, wait. Yeah, motion time would just be that amount because we're all dealing with seconds. Yay, straight math. Alright, so we actually don't really need to calculate time at all. What we do need, though, is an internal float to keep time. Yes. And what we can do is public change time. Make this a void. Have an amount. It's my favorite. Current time is equal to clock animation dot oh shoot, how do I dive into the animator again? Oop. Unity. Grab animation layer. Animation layers, let's go. What do we gotta do? Get all states. Getting a state would be very, very nice. Actually, referencing states are kind of a pain, honestly. You have to go through quite a bit to get there. Get current state info. It's looking for a layer. We're always going to be on layer 0 for this. Dot normalized time. And what that's going to do is essentially give us a 0 to 1 state of where we're at in our animation, so that we can appropriately, time is equal to plus equals to amount, so we can easily decrease time if need be, and then reapply time, which would be clock animation dot set actually we could just get current animation state info 0 again, and then just set the normalized time. Actually, we could shrink this down even further. We don't even need current time. I lied. All we need is this clock animation, and then we just need to plus equals the amount. Right? Yeah? No? Has no setter. Alright, nope, never mind. I was right. We do need this. And then what we want to do is set position, which should be normalized time. Is there a setter? Nope, there is no setters. All right. Well then. Okay, so essentially what we need to do is we need to reset this animation and play it at a specific point. I believe if we do clock animation dot play, then we need a string of the state name. So state name would be timer. And then we can do, I believe, yeah, there's multiples. Int layer, and then normalized time, which would be current time. Beautiful. Last thing we gotta do is just change that animation block to timer, which it is, and we're all set. This should work without a hitch. All right, well, I actually got to run here, so thank you so much for actually sitting in. You were a blast to have. And I will see you around next time. I plan on hopefully making this a normal thing. I don't know exactly what my weekly schedule will be, so I would say keep a lookout, and I will be posting that shortly. I'm pretty much doing this as a way to kind of look back. I'm hoping to go throughout most of the year and see exactly where I start out and where I kind of end. I really enjoy doing this, and I really enjoy being a wild card, so let's see what happens. Again, thank you so much for joining, and I will see you all later.